calculator and go to table function. Okay. So go menu, table function, okay? And what you're going to enter is 600, and you're going to enter E. So that's above the LN button. So you go Shift LN, and then you enter in 0.1144. Only difference is we haven't got an X. Oh, so we haven't got a T. So we're going to get an X. Is that okay? So alpha X. Time, it's T is minutes. So time has to start at 0. So we're going to say is start at 0. If we read down, you can see that stops at, it wants to know what size the population is at 10 seconds, doesn't it? So I'm going to go up to 20 just in case. Okay. And look, what this tells me is, this tells me what happens to the bacteria every minute. You start off with 600. After 1 minute, you have 672 bacteria. Then after 2 minutes, you have 754 bacteria. Everyone's that? Go all the way up to 10 minutes. After 10 minutes, you have 1,883.58 bacteria. Okay? And see the way it wants us to find out when it's at 6,000. I could keep going down here, and I could eventually find where it's at 6,000. I'd say it's somewhere between 20 and 21, would you? It's about to jump there in a second, isn't it? Yeah, so here's what I'm writing. Straight away, I'm going somewhere between 20 and 21. I know that straight away. I know these two answers straight away, don't I? So all you have to do to show your workings is, all you do is write down the equation, and whatever t value they give you, put it in. So all you do is that. You don't even have to enter that into your calculator because it's already done. It's already the first answer, which is 0. 600 is your first answer. Anything to the power of 0 is 1. 600 times 1, 600. Okay, next thing. After 10. So you have to do the same thing again, except you're replacing the t value with 10. But somebody show me, because I showed it twice there already. 1883.58. Yeah, I know. Now, lads, are you allowed to have 0.6 of a bacteria? No. So you have to round down in this case. You have to round down because you either have a bacteria or you don't. So it's not a fully grown bacteria. So you have 1883 full bacteria. Do you get what I'm saying? Okay. Last one. The answer is somewhere between 20 and 21. What chapter are we in again? What have we been doing the last couple of days? We've been doing logs. All right. Now, this part, I don't look forward to correcting these because I correct for the last 12 years. I correct the same mistake every year, and I'm going to show it to you again. Okay, you replace p with 6,000. Whatever t value you put in, and we estimate somewhere between 20 and 21, right? We estimate somewhere between 20 and 21. Whatever t value you put in, it causes the answer to be 6,000, right? Now, I'm gonna do something here, and you tell me if I'm right or wrong. The variable is in the power. See the way the letter we're looking for is in the power. That's a clear indication you got to use logs to find it. So what I'm going to do is I'm going to log both sides. I'm going to use ln. The reason why I'm using ln, actually, if I'm being honest, it doesn't matter what log you use, whether it's ln or log. So for argument's sake, I'll just use regular log. Okay. Now, can anybody tell me, am I allowed to bring this power to the front? Whose hands up if you're a no? Can you tell me why you're a no? The power is not acting on the 600. The power is only acting on the E. Therefore, it's not transferable. Go back a step. So the 600 is causing the issue, right? If the 600 is causing the issue, why don't you, that 600 is multiplication on the right, makes a division on the left. What's 6,000 divided by 600? 10. 10 equals e to the power of 1144t. Okay, now and only now, pick any log of your choosing. Okay, if I was doing this myself, I'd use ln, but if you want to use log base 10, it's no hassle. Same answer, okay? Now, here's what we're going to do. Ready for this? Okay. Bring the power to the front using the power rule. So what is it? 0.1144. I was going to use a capital T just because it looks differently than the number 4. Okay. Log E. Is that okay? And this is log 10. Now, what's preventing that T from being on its own? And what else is preventing it from being on its own? Yeah. And they're both multiplications, aren't they? So here's what we're going to do. We're going to do log 10 divided by log. Okay. Now, we already have control over this. If it's not between 20 and 21, we're looking for a mistake. Okay, so we actually have complete control over this question. And you find a lot of leaving cert questions are the same. You know exactly what you're looking for. It's just about making the question fit the narrative, right? So here's what you're going to do. You're going to go, you have to get out of that for a minute and you go, all right, fraction button, log base 10 is just log 10, right? So we put that in. Now the tricky part here is the 0.1144, and then you have to get log E. So you have to press the shift, see the E button, and E is E to the power 1. There's no button for E on its own, I'm afraid. And put the answer in, 20.13, exactly what we're looking for. Okay, so yeah, no, I thought that was pretty clear and good. All right, scientists can estimate the amount of carbon-14 in a fossil. When an animate object dies, the amount of carbon-14 measured in grams in the object is given by this, where T is the number of years since the death of the object and M is a constant. No bother. Show that M is the mass of carbon-14 in the object at death. Now, at death. All right. Would you agree that the T value is how many years it's dead? So if I say T equals 10, that means it's dead 10 years. If it just died, however, the T value is 0. So here's what we can say. A equals M E to the power minus 0.0030. Oh God. 1, 2. But T is 0, isn't it? Now, if T is 0, what is this entire number? 0. All right, you're on it. And what's any number to the power of 0? 1. So what's M times 1? 1. So would everybody agree that M actually equals A? M and A are the same thing. So this formula actually now becomes A. Yeah, A equals M, yeah. Okay. So M is the mass of the carbon 14 in the object at death. Yeah, done. The A is yeah, I've just had to do it, haven't I? It's just M on its own. Done. Alright guys. An object is 3,000 years old. Find in terms of M. So you get to leave M alone. Just leave M where it is. The amount of carbon 14 in the object. No bother. Here's what we're going to do. A equals M E. And what are we going to put instead of T this time? 3,000. Now, the only thing that you can put into your calculator, the only part that you're allowed to put into your calculator is this part here. So just put that part into your calculator and call out what you get. That's all you got to do. Has to be a positive number. Has to be a positive number. Lads, the seagulls are flying today. Now, lads, would everybody agree with that? Okay, last one, guys, okay? An object now contains half the carbon 14 that it contained at death. Now, half of what it contained at death. This is not too bad, I'll show you now. Okay, so at death, did everybody agree that at death it contained M? We proved that in the first question. So this means A is actually a half M because it has half of what it had at death. And that in turn equals M E to power 0.0012 T, What type of question is it? What's it actually asking me for? How old is the object? What type of variable is that? How old? Time? Is it mass? What is it? It's time. Which variable is time? T. You want T on its own. T is in the power position, which indicates what you need to do. When the letter's in the variable position, you use logs. Log, log, log. That's hold off per sec. Don't be difficult. All right, guys. I'm just going to log both sides. Log a half. Log. Your homework's on Google Classrooms. Put the seats up as well. Power to the front. Yeah, I'll finish this after some post. So lads, log a half, and you bring the power to the front, and it goes minus 0.00012 log e. There's a t there as well. T log e. You basically want this t value here. You want to isolate it. So what you're going to do is you're going to bring this part here and this part here underneath. So you're going to get log a half. So you get log a half, and you divide it by minus 0.00012 log e, and that equals t. You got to put that into the calculator. Difficult to put in, so it's going to be log 0.5, which is log a half, all divided by minus 0.00012 log. Now it's an e, so this is the e symbol here. Shift. There's e to the power 1, which is just e. Yeah, 5776. So t, it's the object is 5,776 years old. Okay, and that's it. So that's questions 4 and 1.